Hello everyone, welcome to your next section. Today we're going to be talking about dictionaries. Dictionaries are another data type that are similar to lists in that they can contain other variables, like multiple types of variables, all within its one object type. However, the way in which we organize our objects within a dictionary are much different. Dictionaries are also in syntax identical to a JavaScript object known as a JSON object, which is a JavaScript object node. So learning about dictionaries is actually going to teach you how information is passed through websites on the internet, as well as how you can access data from a JavaScript file to do some manipulations on it. So by learning about dictionaries in Python, you're actually learning about object types in JavaScript at the moment, which is pretty cool. And it'll help you with web scraping. It'll help you understand a bunch of real practical things that we do with data science and like dealing with large packages of information. So what we're going to learn today is we're going to learn about the data type dictionaries. We're going to learn how we index dictionaries, because I told you the indexing system is a little bit different with them. And lastly, we're going to be talking about dictionary functions. By the end of this lecture, you're going to have a nice understanding of both of these data types so that we can then start running through using for loops on these data types to show you like the power of automation that you can use with this type of object. So, what is a dictionary? A dictionary is similar to a list in that it stores multiple variables within its object. However, how that information is organized is completely different. A list uses the position when an item is placed in the list as its method of index. So if an item comes in the first position of a list, it always stays there. And if you append to your list, it's coming in at the back end of the list. A dictionary is not an ordered collection of variables. It's an unordered collection of variables and uses an index of key and value pairing. So essentially what it does is, rather than the position being your index label, you set your own index label. And it can be anything. Usually we set it to strings, so you call values from that key you get values by eliciting the key within the dictionary to get the value out. And this is useful for a few reasons, and I'll show you why once we get into our syntax. So let us hop into the syntax so you start to understand what I mean by that, because this is a very useful data type that allows you to organize information in a different way and call very specific things when position means effectively nothing to you. So here we are in our syntax section. This first line here is how we call or initialize an empty dictionary. It's just like how we initialize any variable. We label our variable first. We then use the assignment operator. And these curly braces, that's what we call it, curly braces, are the syntax for a dictionary. Curly braces are located where your square braces are. It's just the shift button, and then you press the square brace. And so what we've done here is initialize an empty dictionary like we did initialize an empty list the first time. If we wanted to initialize a dictionary with values already in it, here's the syntax for that. So first we do our first dictionary equals assignment operator, and we have our curly braces. And so what we're seeing here is, notice that we have comma right here. So this is actually delineating between two values in our dictionary. And what you're noticing is that each of them has a colon, okay? So the first value you see here is what we call the key. That is what we label our index position to be. And then we use a colon to tell Python that the key has been completed, like we've initialized our key, and that we want to put some information next to that key to create a key value pair. So this is key, and this is value. Now, usually you only want your keys to be strings. You can set them to be floats or integers, but you'll probably run into some problems later on with that. So I want to tell you guys for now, set all of your keys as strings. It's just going to be easier for you in the future, and once you get a better mastery of dictionaries, you're going to understand why I'm saying that, but also when might be a good time to use integers or floats instead. Basically, if you were to like TLDR is if, let's say, you wanted to save this dictionary to a file and then call it later or pass it on to something else. If this isn't just a number and not a string, it's going to convert it to a string anyways. So for ease's sake, just for now, at least accept that you should probably make all of your keys as strings and key labels that make sense. So this dictionary is clearly giving some biographical information. It's saying, okay, well, this person has an age key variable and that the number is 32. So we have associated age with 32, that must be 32 years old. And then we have another one here that says name and another string. So we said that keys should always be strings, but values can be anything. They can be, a list. We see strings and integers here, so it can be a float, it can be a Boolean. You can actually have your key be name and have the value be another dictionary. So you can have embedded dictionaries within dictionaries, and so on and so forth. So the most important thing with syntax for a dictionary is that you set your key, you then use the colon function, you then press colon to say, okay, I've completed labeling my key, and then pass in the value, whatever that value is, list, integer, float, string, Boolean, whatever you can imagine. And then once you're done with adding an element to that dictionary, you use the comma to then include other ones. So how do we access information from this dictionary? We can't do like first dictionary of position 0 because there is no position. The positions are labeled as these keys here, almost like we're calling a variable. So how we end up doing that is like with indexing in strings and lists, we call the object and we use the square brackets like this, but rather than using a position number, we call the actual label. We call the actual key that we want to elicit a value. And so what will come out of this response in Python will be 32. Okay, let's say you wanted to add information to this dictionary and not retype this whole thing here. How would you go about doing that? Well, it's almost exactly identical to what you did up above with indexing. You create the index. So we know for a fact right now that height doesn't exist. But if we wanted to add a height variable, we create a new key label, which is height, right here. And then we use our assignment operator to say, okay, this is a new key pair, or key, and we want to add a value to that new key. And how to do that is to use the assignment operator. So that's how you add information to a dictionary. You don't use like a .append function, for instance, because append is just going to put it to the end of a list, and because position doesn't matter in a dictionary, that's not very useful. So this is how we add values to dictionaries. Okay. Last thing I'm going to show you are two functions. We're going to look at a few other functions when we get into our code. But let's say you have loaded a dictionary and it's a very large one, or you've never really worked with that dictionary before. If you want to know what labels currently exist without seeing millions of values pop out and not really have a sense of what's going on, you can call your dictionary and then run the .keys function. And what this will do is it will give you all the keys that exist in your dictionary at the moment. If we ran this command, it essentially just provides a list with each of the key labels, age, name, and so on. Okay? But that's all it's going to show you is just the keys. It doesn't give you the values. The .values function, on the other hand, will give you each value as a list as well. So in this case, you're going to get a return of 32 as a list, 160 because we created this height variable, and Michael. Okay? So that is the basic syntax for dictionaries in Python. Let's hop into a Python console and see how this all comes together now. Okay guys, here we are in base Python. Remember that I'm on a terminal. I'm on a Macintosh computer. I was in my default directory when I opened this up, and I ran Python to get into our Python console, which has these 3 chevrons. That's how you know you're in Python and not bash or command prompt at the moment. So first off, let's create our first dictionary. Let's calling it FD because it's easier to type. That is initializing an empty dictionary there. Let's look at the type here. It is indeed a dictionary. So let's see what kind of functions are available for dictionaries. We're going to scroll all the way down. Consequently, guys, if you don't want to do this from console, you can also go to Python's website to get all this documentation, and it'll give you more background as well if you'd like it. So some functions that we might be familiar with from before, we see the .keys function. .get is very useful too. So if you give a key, if you use .get and provide a key, it will return the value for it. You have .pop, which will remove a value from your dictionary and return the corresponding value if it actually was able to remove. If you couldn't find the key, it's going to error for you. It tells you all that there. .items is very useful, and we're going to go through that function a little bit, and that's going to give you keys and values provided in a list of tuples. And then there's a couple other things that you can look at here, but those are the ones that we're going to touch at the moment. So remember, in order to get out of our help menu, we're now going to press Q. Let's look at our dictionary. It is indeed still empty, so let's try and populate our dictionary with some values like we did before. So age, 32. So remember, in order to create a dictionary element in Python, this is the syntax required for a single element. So you need to provide a key. Usually that's a string. The first element within this, between these colons, is the key. So on the left-hand side, you label your key value, your key. In this case, we're doing age, colon, and then what's to the right of the colon is the value to create a key value pairing. Next, we're going to create a name key, and then add a value for that name. I'll just put Mike for now, and indeed that works. Let's look at this dictionary now. It does have that information. You'll notice that it kind of changed the double quotes to single quotes, but that's okay. It's just saying that this is a string and this is the key for that string. If we wanted to add something to this dictionary, how we do that is, well, first let's just call something here. Show how that works. Age, okay, so we asked the dictionary that now has this information to return to us the value associated with the age key, and in fact did. It returned the integer 32. What happens if we try and put in what happens if we try to ask it for something that doesn't exist in the list right now? It says key error. It says, okay, I tried to find the value for this key called height, but I can't find height in our dictionary. It's empty, like there's no height value, okay? So let's add a key value pair to our dictionary and see if that'll work again. So let's add height to our dictionary. So in order to create or add a key value pair to a dictionary, first, you use very similar to the indexing where you're trying to find a value for a key. So you use the square brackets, just like with strings, and you provide to it the label that doesn't exist currently. You then use the assignment operator, which is equal, and then you provide the value to it. And you see here, no errors, and in fact, we do have a new key value pair in our dictionary that's height. Now what happens when we try and call that? It indeed works. So there you go. So that is how you select indexes, or you index a dictionary in Python, and how you kind of find values using your keys. The next thing I'm going to show you is a couple of functions. So first off, what happens if you have a very large dictionary, or a dictionary that you haven't been exposed to yet, so you don't know what keys are in there? You can look through the keys by doing the .keys function on your object. And what it returns is it says, I have a dictionary keys object, which is a tuple, and it contains, the tuple is a list of all of the keys, okay? So this tells us every key that exists in this dictionary. So then we can, either we could do some sort of iteration across using this list, with a for loop that you'll learn about in the next section, or at least you can, make sure that you know what exists in your dictionary so you can access information. Next, I want to show you what the .values function does. It's almost identical, except for rather than providing the keys for each of the dictionary items, it provides to you the values, and they come in basically the same order, okay? So you notice that it did age, name, and height. This will also return the values for age, name, and height in the same order, and that's important if you're going to use some functions with dictionaries. The last thing I'm going to want to show you is the .items function. Actually, why don't we do a removal of a dictionary value? So we can do fd.pop, and we'll put in age. And what pop does is it will return the value that you popped out, but in fact does also remove it from the dictionary. So you can .pop also exists in lists. So this function, there are functions that exist across data types, and this is one of them. So if you're familiar with .pop from lists, it works effectively the same way. Okay, the last thing I want to show you is the .items function. what this ends up doing is it creates a dictionary items object, which is a tuple, and this tuple contains a list of values, and the values are, each value in the list is a tuple, which the first element of the tuple is the key, and the second element is the value. So you can look at this, you can do like an iterative, you can do a for loop with your dictionary, or do some sort of like ordering or something to that effect to like find specific information. You do use the .items function for a bunch of tasks in Python, so it is useful to understand that this does exist. If you want, once we start iterating with dictionaries with for loops, you'll notice that you don't have to use the .items function specifically, but there are uses for .items and .values that will become apparent as you play around with Python more. Okay guys, with that, let's just do a quick recap. What we learned today, we learned about dictionaries, we learned how to manipulate dictionaries, the syntax of a dictionary, adding values to them, removing values, how to index them, as well as a handful of functions that are useful for loops and other types of iterative processes. So in next class, we're going to introduce you to looping, which is a very, very important concept in all of code, and it's going to really make your ability to automate processes super powerful. So looking forward to seeing you in that chapter.